If someone asks you,
Well,
what is a limit? What would you tell them? If you are a Florida driver, don't even think about it. Don't know what speed limit is. But aside from speed, if someone said limit, what does that mean? Corbin,
The end value of
come again?
the end value of something.
The end value of something, well, going back to speed limit, if the sign says 70, then the maximum that you can get to technically is 70, right? Yes?
Wow.
So, but we go 5 over, that's fine, but I get honked at, even if I go 5 over.
do you stay in
someday-
the right lane or the left lane?
Okay, now I know how you drive. Right, when I go 5 over, right, even then I get honked. On time. Limit is a value that you can't reach and you pretty much stop. Some functions would give you an exact limit. In that case, it's not even a limit, it's rather a balance. So limit is what you are trying to reach. First point, every function has a limit at some x is equal to c, or it is undefined. But let's not put it as undefined, rather say plus or minus infinity, because it's calculus. For some, it is D and E. When you do your homework, it will probably ask if it's D and E. D and E stands for does not exist. You might find this statement contradicting that statement. Without getting into too much detail, there is a difference between a limit and a one-sided limit. It is also a limit, so there will be a limit of some sort. It's just not going to be a full definition of the limit, which is why I wrote that statement. But in some cases, we write it as does not exist. Okay. In algebra, in high school, middle school, whatnot, 1 divided by 0, taking the easy case, what is that?
Undefined.
Undefined. Those are baby, that's baby math. It's no longer undefined. This is where limit comes into play. Good. So 1 divided by 0, thus far you would have landed as undefined, but it's not actually undefined, it just has a limit. Good? Okay. Let's erase this. Second note. Easier way to recognize whether a function is going to have a limit or not is to simply ask the question, is there an asymptote? If a function has an asymptote, may it be horizontal, vertical, oblique, oblong, doesn't matter. If there is an asymptote, it will have a limit period. Thomas,
What is an oblique asymptote?
Huh?
What is an oblique asymptote?
great question. Something that goes like that. I don't think you'd encounter that in business, but if the asymptotes go in a diagonal direction, then it's oblique. Any other questions? So then to look for a limit, anytime you have an asymptote. Good? Okay. Without the concept of limits, one cannot understand derivatives. Sure, certainly, some of you might simply take the derivative and follow the algebraic process and come up with the derivative. But if you can't explain it to someone, say 10 years from today, what is the point of learning a derivative? If your kid comes up to you and asks you, Mark, Dad, explain what a derivative is, it's in my calculus class, and you just there, your kid is not going to have a great impression about you. So you've got to look smart. Try to understand something. Set a good example. So you can't understand derivatives if you don't understand limits. Good. One other pointer. Can I write here? Right. Suppose y equals f of x is some function. I'll even define it to make things easier. Let's do 3x minus 2. What type of function is that?
Linear.
Linear function. It's a line. Okay. And if I asked you what is f of 2, what would your answer be?
Or
Quattro.
What? Quadratic what?
It's
Who said quadratic?
No, quattro is fours, man.
Oh, I see. Breaking my heart. 6 minus 2, 4. The value is 4. That is the exact value of the function when x is equal to 2. Do you agree? Okay. I want to start with something simple, which is why I'm going with a linear function. Um, I want you to pick up your calculator. I want you to plug in the values. 1.99, 1.97, 1.92 for x, 2.001, 2.01, 2.02 for x. And you can tell me what the y values are. We are going to do it the hard way, but I'll show you how to do this easily next time, which is why you need your calculator. You made that face, why?
Right. Plug it in this equation.
Yes, in f of x like that. We'll start at 1.92. What is the value of the function?
3.76.
3.76. Next,
3.91.
3.91. Next,
3.97.
3.97. Okay, let's start at 2.02. Very good.
4.06.
Come again,
4.06.
4.06.
4.03.
4.03.
4.003.
4.003. Okay. 2 is right here, and all of the values that I picked are to the left of 2. Do you agree? Yes?
Plug in all the x and then I get to y there, but this is y.
The values below 2 are to the right of 2. Agreed? Yes. What is happening to the value of y as the x value approaches 2 from the left and the right? What is happening to y? Are you? Let's pick this. You are getting closer and closer to 2 from the left-hand side. What is happening to the value of y?
It's getting closer to 4.
Okay. It is increasing, going toward what number? 2.
4.
The y value, 4. Okay, x value to y value, 4. Start from the right hand side as x approaches 2 from the right. What is happening to the value of y?
It's decreasing.
It is decreasing, but it is getting closer and closer to
4.
4. Good. Both values get or converges to one number uniquely, and that's one number is 4, right? And that one number is the value of the function, correct? So what you know as the value of the function is nothing but the limit of the function. Good? We don't use the word limit here because of the nature of this function, which is continuous. There are cases where we won't call it a value, rather we'll simply call it the limit. Good? Okay, what are we bringing next, guys? Calculator. Before you come to class next time, I want you to look up one thing. Piecewise function. Good? Just look at it and then we go from there.